Ask My Instructor 11.3.28. Find the area inside the lemniscate and outside the circle. The general shape of the lemniscate is a figure 8. Let's plot a few points to see what is going on. The angle is doubled, so I'm going to start off with some fairly small angles. Also, we have to consider that solving for r means we have a plus and minus option. So I evaluate r squared, and then r would be plus or minus the square root of that. Looking at the red dots, those are the positive radii. Looking at the red dots, the radius starts at about 4.9, and that's where theta equals 0, and works its way to 0 when theta gets to pi over 4. Meanwhile, with the blue dots, the radius starts at negative 4.9 when theta equals 0, and works its way also to 0, this time moving in a clockwise direction. And the complete graph, so the graph is completed when we add the points for theta being pi over 4 to theta being pi over 2. Alright, so we have the graph, and now I'd like to ask, where does the lemniscate and the circle intersect? Well, what I'm going to do is I'm going to square the equation of the circle, so I have r squared equals 24 cosine 2 theta and r squared equals 12, and so the intersection will occur when 12 equals 24 cosine 2 theta. Solve for theta, finding the smallest positive answer. So we just want the first positive occurrence. So to solve for theta, I first solve for cosine 2 theta. Cosine 2 theta equals 1/2. Where does cosine equal a half? Well, cosine equals a half at pi over 3. So when 2 theta equals pi over 3, I'll get cosine of 2 theta equals a half. So theta would have to be pi over 6. And the graph confirms that there is an intersection when theta equals pi over 6. So to find the area inside the lemniscate and outside the circle, what I'm going to do is I'm going to find the area inside the lemniscate and outside the circle just for 0 to pi over 6. And then I'm going to multiply my answer by 4. And the reason for that is, remember how r gets all funky, and sometimes it's positive and sometimes it's negative? It's really best, whenever possible, to use symmetry. And so that's what I'm going to do. I'm going to find the area inside the lemniscate and outside the circle from 0 to pi over 6. And then you can see I have 4 of these, so I will just multiply the result by 4. So that's what I'm going to do, is just focus on these that one little section. Alright, so let's do that now. The equation of the lemniscate is r squared equals 24 cosine 2 theta. So the square of the function r equals f of theta would be r squared equals f squared. So f squared is 24 cosine 2 theta. That's a little confusing. Hopefully I cleared that up for you. Meanwhile, the equation of the circle is r equals radical 12. So the square of r equals g of theta is r squared is 12. So g squared is 12. It's kind of funky because one of the equations was given as r equals something, and that's the usual format. The other one was given as r squared equals. So anyway, outside the graph is f squared. Inside the graph is g squared. Therefore, I'm going to be the length or the radii of my little sectors is going to be f squared minus g squared. So I have my setup. I'm going from 0 to pi over 6, and my f squared minus g squared, I have that. And so I just do my setup here, and it's time to integrate. So of course I like to simplify first, and then I integrate and evaluate. And of course that evaluation takes a lot of work in simplifying to make sure you get it okay. And so the area inside the lemniscate and outside the circle from 0 to pi over 6 is 3 radical 3 minus pi. So the total area is 4 times that, 12 radical 3 minus 4 pi. And we're all done here. Take care and have a great day.